being with me in this journey of making these videos about Julia and sharing some interesting fact with you. So in this session I'm going to show you some state-of-the-art syntax is provided by Julia, and how we can do algebra very efficiently in Julia. So this is the first thing that I'd like to show you, and Julia is calling it numerical literal coefficient. And as you can see, and I think you already have guessed that this is actually 2 into x to the power 2 minus 3x plus 1, and this is 1.5 into x to the power 2 minus 0.5x plus 1, and yes, this is 2 to the power 2x. And if I save and run this, so I am running the same program from my last video, that's why those are coming. Okay, so now please focus on this. Is x equal to 4, m equal to 21, and yes, you're smart people, you can calculate. Okay, and we also use a new operator. This is an unary operator, root, and I already have shown you how we can write root, and we can do the same, root over 4 and then x. See? Okay, few more examples on the same topic. So here this is x minus 1 into x, and this is 2 into x minus 1 to the power 2, and this is 3 into x minus 1 plus 1. Fine. Now let me show you some exceptional examples. What if we run this? I think you already have guessed that we are going to have an error, but let me show you what is the error. So it is showing method error, like some method we are trying to call, and what it is saying, object of type int64 are not callable. Int64. Let me remind you, we are running on a 64-bit machine, and the default size of an integer is 64-bit. Now when in this equation, when it is getting evaluated, it is actually evaluating to a int64. Now kind of int64 is a data type, and this is kind of a function notation. In fact, Julia is interpreting as a function notation and trying to call it, but we cannot call int64, and same goes here. We cannot call this. Okay, first this is compiled language, so it will stop compiling. It is showing as the same line number 43. So now it should show for 44. Yeah, 44. But we can mitigate this hopefully by this one. Let us have a try. No. Then we need to have some higher priority operator. Still not working because it is a function call. Again, Julia is thinking this is a function call. And last but not the least, unary operator. This unary operator can work on constant and obviously on variable, but in this case it will not work and it is going to throw us an error, and in this case it is considering this as a token instead of an operator. Okay, so those are the few points that I'd like to share. Let me try this. I think this should work. Yes, this is working fine. So see you in the next video. Till then, bye bye. And yes, let me know your thoughts and your experiment in the comments. Bye.